Today we will cover the topic of glycolysis, the second anaerobic pathway that the body uses in order to produce ATP. Before getting into all the specifics, it is important to note that glycolysis takes place in the sarcoplasm of the cell rather than the mitochondria. It is also important to know these two key words, kinase and dehydrogenase. These are two enzymes that energy systems need to function. Now that we know these important aspects, we will move on to how glycolysis starts. First, we need energy. To get this energy, an already present ATP has to have a phosphate group removed from it by hexokinase. The high energy bond between it and the other phosphate will provide the energy needed to get the ball rolling. There are several steps involved, but the ones we will focus on today are the ones where we either lose energy or gain energy in some form or fashion. The first one was stated earlier, the ATP that was used in order to get the energy needed to start the breakdown of glucose. The next would be step 3, when fructose 6-phosphate becomes fructose 1,6-biphosphate. The enzyme used in order to convert ATP to ADP this time would be phosphofructokinase. Notice how we have once again lost energy. So how is glycolysis helping us to get energy when we seem to just keep losing it? If we move on to step number 6, the reduction of NAD+ to NADH+ plus H+ is made, and we can find hope because NADH plus H+ will go on to our next system to make energy. During step 7, glycolysis directly produces energy. Biphosphoglycerate uses phosphoglycerate kinase to move a phosphate to an ADP to produce an ATP. At step 10, phosphoenolpyruvate uses pyruvate kinase to shuttle phosphate to ADP to make another ATP. At this time, the product pyruvate is also produced. Now it's time to wrap things up. For every one glucose molecule, the process of glycolysis is repeated twice. Glycolysis directly produces 4 ATP, but due to the loss of 2 ATP, there is a net gain of 2 ATP. The other products of glycolysis are 2 NADH+ plus H pluses and 2 pyruvates. Glycolysis has a relatively high power output and lasts for about 30 to 180 seconds. Next time, we'll talk about the Krebs cycle, which takes longer to power up, but will lead to the production of much more energy for a much longer time.